Welcome to this lecture, Relational Algebra. Relational algebra defines the basic set of operations of relational database model. Relational algebra is a collection of some sample and is a procedural query language. So, first of all, here selection operation displays a subset of tuples or rows in any DBMS of a table that satisfies certain criteria. So criteria is here sigma city is the column name is equal to Multan, means where city column is equal to Multan, and here is the entity or table name or relation name is here. So we are going to select employees where city is equal to Multan. So let's begin with implementation. So test data is our database and here are the tables. So employee table, so we are going to use some sort of operation, select all from, because we are going to perform selection. So from employees table and where city is equal to Multan. Execute the query and here is the result. And next one is projection operation. Projection operation displays a subset of fields or columns of a table that satisfies certain criteria. So here pi symbol which indicates projection operation, and criteria is here ID and name from employees table. We are going to select only ID and column attributes from employees table. So implementation time, so perform here select ID name from employee. So here is the result of projection operation. Now the next one is combination of selection and projection. So in single query we are going to perform the combination of selection operation and projection operation. So here by using select query ID name from employee where city is equal to Multan. Execute the query and here is the projection, because we are going to select only two columns, and here is the result of selection because only employees are here, those are from Multan. And next, join. A join query is used to combine rows from two or more tables based on a related column between them. So a join operation in relational algebra combines columns from one or more tables in a relational database. It creates a set that can be saved as a table or used as it is. A join is a means for combining columns from one or more tables by using values common to each. So here is the first one, union. But here is the question, that why we are discussing this? The answer is in next slides. So union, the union of two relations R and S, these are the names of relations defines a relation that means a new relation that is going to define that contains all the tuples of R over S over both R and S. Duplicate tuples, here is the important keyword, that is duplicate tuples being eliminated or removed. R and S must be union compatible. So in union we are going to take all the elements of both the relations, but repeating elements will be select on once. So here is the example of union operation. A, what is meant by union compatible? Union compatible means C is integer type with size of 11, then D must be or A must be integer type size with 11. So for example, table R and here is table S. So 1, 2, 3, 4. So union compatibility means we are going to perform R union S. So R S here 1, 2, 2, 3, 4. So only common elements from both. So common elements or not, sorry for that, only all the elements from both, but common elements will be removed, and or we can say that at once. So duplicate tuples being eliminated. So 1 is here, 2 is here, and 2 again. So remove this one, and 3 is here, 4 is here, and result is here. So it is time for implementation. Now for this, create new one, test, and here create a table which is S, two attributes A, B, 11, 5, varchar, save it, and create another one, R, two attributes C, D, integer 11, and 5. So select R, go to insertion tab. So 1, A, 2, B, go to S, insert 3 and 2 again in S table. So C and D. So click on go button. Now perform union operation. So in R 1, 2, AB, but in S 3, 2. So result will be 1, 2, 3. So by using projection operation, select A from R union, select C from S, and execute the query. Sorry, the result. Just delete AB. Okay. Select So A from S union, select C from R, first select all and copy. So result is here 1, 2, 3. 2 is eliminated due to repetition. So here is the union operation result. The next one is intersection operation. So intersection operation displays tuples that are common in both the relations. So the intersection operation defines the relation, means it is going to create a new relation consisting of tuples that are in both R and S, where R and S must be union compatible. So both the tuples that are in R and S, so tuple 2 and here 2, both in R and S. So R intersection S, the result is here in black table. So table R and table S, but union compatibility means, I repeat once again, that C is integer type with 11 length and A is integer type with 11 length. So we have two tables, R 1, 2 and S 3, 2. So in result only 2. So select all from R and inner. So by using inner join we can get this result. Select all from S. So simply no need to write again, select on S dot A is equal to R dot C. So execute the query and result is here only 2. So by using projection operation you can select only specific columns. So here R dot C. So only 2 is here in the result according to our plan. And the next operation is minus operation. And in minus operation displays the result consists of tuples that are not in second relation. So means the difference operation defines the relation of tuples that are in relation R but not in S, where R and S must be union compatible. So R minus S is equal to only 1 because 2 minus 2 nothing and 1 is here. So R minus S result in black table. Now we are going toward implementation of R minus S. Here write a query, select R dot C from R where R dot C not in, write a query, select A or S dot, S is a relation name and A is an attribute name from S. So copy the query and execute the query, and here is the result according to our situation. Like 1 is here, So r minus s means 2 minus from 2 from r, so result will be 1, r minus s.